Okay, now let's go into the classification of validity. We will discuss four categories of validity, respectively four categories of threats to validity. These are the most important ones, and therefore we focus on those. Fundamental to understanding the notion of validity is to go back to our general model of research, or more precisely of empirical research. We said that in empirical research we want to have a theory on the one hand. This is here shown on the upper half of the graphic, and we want to draw conclusions based on observations, on empirical studies in the real world. And actually all of that is in a larger embedded in a larger cycle, as I discussed earlier, in the sense of we draw conclusions from the experiments, we may refine our theory, and so on and so on. But for an individual experiment, we look only at the specific relation. We want to have a specific cause for which we expect a certain effect, and this we want to study. This is shown here in the upper half of the graphic. With our theory world, there's a certain abstract cause. It is here called a cause construct, and an effect construct, meaning whenever we apply a cause of a specific kind, we will come up with the effect as described on the right-hand side. This would be a cause-effect that we expect, and that is a cause-effect construct we want to conclude from our experiments. However, we live in the observational world, in the empirical world, so we have no possibility to do this abstract cause construct, but rather we need to translate it into individual treatments we look at. The treatments are different variations of potential causes, and in particular, whether the cause is there or not. So let's say, for example, we assume that developers are more productive under pressure. And this is just an arbitrary example. So our cause construct would be we have pressure on the developers. Our effect construct would be the productivity. Our cause-effect construct would be if there is more pressure, people become more productive. Now, our observational treatment would be we will have pressure, perhaps different levels of pressure. We have to define that as part of our research design. And in particular, we will have no pressure to identify and to compare relative to the case with pressure. Then we will have an outcome. This outcome will be what we actually observe in terms of productivity. And this leads to the treatment outcome construct. That is what we can actually see in our experiment, in our study. And there is a certain relation between the cause construct and the treatment, respectively the effect construct and the outcome. And this is basically the translation. So the experiment objective is basically, what do you think you want to study? And this is in the theory world. The treatment is, what do you do? What are the treatments that you apply to a specific experiment? The various options of what to do. The experiment operation is what you test, how you run the experiment. The outcome is what you see. And now we already have numbers in this graphic, and they basically relate this to the different forms of validity. So conclusion validity is a statistical relationship between the treatment and the outcome. Can we observe that in a statistical sense there's a reliable connection between if we apply a certain treatment, we will have a certain outcome? Meaning, for example, we apply pressure, we have higher productivity. Internal validity is there a causal relationship between the treatment and the outcome? Because from a pure correlation, we cannot necessarily conclude that there is also a causal relationship. So internal validity goes beyond pure conclusion validity. Then there is construct validity, and construct validity we have here on the left and on the right. And this is the relation between theory and observation in general. Is what we actually do in the experiment, is this a reasonable, is this an adequate representation of what is existing in our theory? Then there's external validity. That is there a causal relationship between the construct of the cause and the effect? That's basically, we try to go back to our theory world and try to understand whether there is such a causal relationship. So on this slide, we have again the classification of the different types of validity. Just to summarize, for conclusion validity, we have to determine whether in this study is there really a sound statistical relationship between the two variables. So this is basically asking for statistical correlation. Internal validity is assuming that there is a statistical relationship in this study, meaning we already showed conclusion validity, we assume conclusion validity, is a relationship a causal relationship. That's not trivial because correlation is not causation. There are cases where you have a statistical relationship and they are not truly causal relationships. For example, both constructs may depend on a third thing, may be caused from that, and they may actually be caused in a simultaneous manner from that. Then there is construct validity. This basically is, can we claim that the study reflected well our cause construct and that our measure reflected well our idea of the effect construct? So is this what we did in the experiment actually? Is this a sound representation of what we mean with the theoretical construct in the first place? In particular, this means because we always have in an experiment to look at specific cases, is it broad enough, general enough to be adequate? Or is it only a very, very specific case that is not general enough to represent the generic concept? Then there's external validity, assuming that there is a causal relationship in the study between the constructs of the cause and the effect. Can we generalize this effect to outside the scope of our study? Meaning, can we only say in our study there was a causal relationship, or can we, with a reasonable certainty, assume that this relation also holds on cases we have not seen in our experiment? Let's go through that perhaps for the example of a physical experiment. We may have a situation where we want to understand the law of gravity, and we have as a cause something is in a gravitational field, and we drop it, and the effect is it is constantly accelerated because there is a force. This is a causal effect construct. Gravitational theory is in the theoretical world. What we do is we look at specific cases. For example, we drop a stone, we measure the behavior of the stone, and we see it accelerating. However, the specific way of its acceleration may differ because we do it in an atmosphere, and then it's not constantly accelerating like it is accelerating without atmosphere. And if we do such an experiment with a stone, we cannot automatically be sure that for any object this gravitational experiment will hold. It may be different if instead of stones we look at feathers, we may look at biological entities like people or insects or whatever, and there may be reason why this is not generalizable, what we see in a stone, to other cases. So this would be external validity. External validity is extremely important because that's what we ultimately are interested in. We're not just interested in saying, well, in our experiments it was like that. We are interested in saying, well, for future cases it will be like that. And that is what external validity is about. There are many different threats to validity, and they are well beyond what we can discuss in this very short summarizing chapter. So there is, for example, for conclusion validity, there is low statistical power, there may be violated assumption of statistical tests, there's phishing, sometimes also called p-hacking. There may be problems with the reliability of the measures, with the implementation of the experiment, and so on. Then for internal validity, there may be things like the history, there may be future earlier iterations that impact all that. Maturation, meaning with experience things change, the instrumentation may be wrong, etc., etc. Similarly, for construct validity and external validity, there are many things that just may go wrong. We will not discuss all of them, but if you do some study and you want or need to discuss threats of validity, which you always have to do if you do some empirical studies, then there are basically overview books and literature. Please look into those and look up those cases which we did not yet discuss for doing a full discussion. Let's again go to a small exercise. So A, what is external validity? B, what is construct validity? Just try to recall it without looking back at the slides. Write it down for yourself. Take a moment, stop the video now. Welcome back. So now, what is external validity? It describes whether the results of a study can be generalized beyond the study to the rest of the world, basically. What is construct validity? It describes whether the treatment and the outcome in the specific analysis or experiment truly represent the cause and effect constructs we are interested in from a theoretical point of view, meaning we really measure what we think we should measure. Now let's discuss the individual cases or the individual types of validity. Let's start with conclusion validity. Conclusion validity is basically describing whether the kind of conclusion we draw is supported by the data. Meaning we are looking at the experiment operation and we try to identify whether that statistically makes sense. So threats to conclusion validity correspondingly are issues that affect the ability to draw the correct conclusion about the relations between the treatment and the outcome of an experiment. Examples for that could be choice of statistical tests, choice of the sample sizes, the care taken in the implementation and measurement of an experiment. So everything that we did discuss in the chapter on statistics, what can go wrong, falls into this category. All of this may impact the conclusion validity. It's the first type of validity we need to look at whenever we analyze an experiment. What do we mean with low statistical power? The power of a statistical test, i.e. the ability of the test to reveal a true pattern in the data. If the power of the test is too low, for example, because we have too few subjects, there is a high risk that an erroneous conclusion is drawn. Another very important case are violated assumption of statistical tests. every statistical analysis makes assumptions about the underlying data. There's actually multiple such assumptions. If you use a test that has not been designed for the situation that it is used in, then even though the test is statistically perfectly correct, you may end up with inadequate conclusions. So for example, many statistical analyses assume that the data is subject to a normal distribution. If this assumption is not true for your data, you're likely to get an incorrect estimate of the true relationship. And that can either be that you see a relationship where there is actually none, or the other way around. The next kind of validity is internal validity. Threats to internal validity are things like the influences that can affect the independent variable with respect to causality. There can be threats to the conclusion about a possible causal relationship between treatment and outcome. Typical examples of these kind of threats to validity are instrumentation, for example. The effect caused by the artifacts caused by the artifacts used for the experiment can be wrong. For example, if we have data collection forms that are inadequate, we have a document that needs to be inspected that is not adequate for the task. Another category may be ambiguity. There may be ambiguity about the direction of the causal influence, for example. If we want to research, and we may actually assume that A causes B, but it may be that B causes A, or even there may be a completely different issue, X, that causes A and B. Let's take again an example. If a correlation between program complexity and error rate is observed, if there's a high program complexity, it can cause high error rate, or vice versa. Or if there's the high complexity of the problem can actually impact both. So it's not like I have a particularly complex program or particularly high error rate. I simply have a very complex problem to solve, and that leads to both. The next category are the construct validity. That is basically whether the realization in the experiment really corresponds to the underlying construct that we have in the theory world. So it's basically answering whether the experiment setting really reflects what we think of in a theoretical point of, or from a theoretical point of view. If we are looking for a causal relationship, we need to make sure that the treatment reflects the construct of the cause well, and that the outcome reflects the construct of the effect well. Again, let's look at such an example of a problem. So here we have the problem for construct validity that we may translate the absence or the presence of prior knowledge into our treatment. But actually what we are looking for example, good development or well understandable code, may not just depend on whether there is or is not any prior knowledge in a programming language, but actually whether subjects have 1 year or 3 years or 5 years of experience with the language. So it's the amount that may have an impact as opposed to just whether there's a yes or no relationship. In that case, the construct validity would be impaired and we would not have an adequate construct representation. External validity. In this case, we look at whether our validity is really representing adequately what we expect on a theory level, meaning there is a cause-effect relationship adequately, and whether that is really supported in a general manner by the experiment. So we have here threats to external validity. These are any concerns that impair the ability to generalize experimental results outside of the specific experiment setting. And the experiment setting will always be just a very narrow case, giving the large range of possibilities. 3 typical risks could be we have the wrong participants as subjects, meaning the wrong kind of people. We conduct the experiment in the wrong environment, and we may perform it with a timing that affects the results. For example, if we give participants too little time to do it, then we are actually measuring speed, not really the capability of people. Typical threats to validity or to external validity can be the interaction of the selection and the treatment. There may be an effect of having a subject population not representative of the population we want to generalize to. So, for example, selecting only programmers in inspection experiment when programmers as well as testers and systems engineers generally take part in the inspections. So we just have the wrong type of subject. A very, very common case for that is if we look at a lot of experiments that have been done in software engineering, and they have actually not been done with professional subjects, but they have been done with students. There has been a lot of debate on that. It's typically done because it's much easier to get a large number of students than a large number of professionals. And in some sense, they're also way more homogeneous than professionals are. So all the other kinds of validity, like the conclusion validity, because you have larger numbers, you have better kinds of tests, like the internal validity and so on, all of that is way nicer, but external validity is a concern. However, even so, it's clearly not the same population. It's really not fully representative. The overall results are actually pretty positive, that by and large, given the range of variation, student experiments can be used pretty well as a proxy to experiments with professionals, at least if software development is the key question. Another concern for external validity is the interaction of the setting and the treatment. For example, if we have not the experimental setting or the material that is really representative of the case that we are really interested in. For example, we use very specific perhaps old-fashioned tools or just experimental tools in a research environment, in an experiment, when actually completely different types of tools are common in the industry. If this type of tools may have an impact on the experiment, we may have an issue in terms of external validity. Let's have a look at another exercise. Which types of validity are impacted by statistical issues? You may have multiple answers. Think about it, stop the video, and then return with your answer. Welcome back. Here's my answer. Conclusion validity is really at the heart of statistical testing. So that's obviously a correct answer. However, our causal relationships we are looking at in internal validity are only true if we assume that the statistical tests are correct. That means the statistical testing or any statistical issues that impair conclusion validity will also have a secondary effect on internal validity. And because that has also an indirect effect on the external validity, that will be impacted as well. So actually my answer here is these 3: conclusion validity, internal validity, and external validity.